Okay, today we're going to look at normal distribution. We did a little bit in class, but I know that it was at a time when lots of people were away. So I'm just going to go over page 76, and then I'd like you to do page 77 to 80. And then on Friday we're going to have a test. Okay, so it says, if the weights of tuatara, a rare New Zealand ground-living lizard, are normally distributed with a mean of 680 grams and a standard deviation of 95 grams, answer the following questions. Calculate the percentage of tuatara that weigh less than 700 grams. Now, the calculator is so amazing. It does this for you. So now we're going to distribution and normal distribution. And almost every single time we're using NCD. So there's no decision between NPD or NCD, always doing a range of values. Now it says calculate percentage of tuatara that are less than 700 grams. Now that means I need, if I draw a diagram, oh, it's terrible at this end. I'm going to do that again. So if I draw a diagram, my mean is 680, and I want the percentage that weigh less than 700 grams. So that's going to be all of that. So 700 is here. So that means my upper value in my graphics calculator is going to be 700. My lower is not going to be 0. What I'm going to do is I'm going to write a negative, but a huge number. And then my standard deviation, which is this symbol here, is 95. And my mean is 680. Now what you need to do in your calculator is, in your book, is write the stuff here, down here. So the examiners know that you've put it into your graphics calculator. But I'm not going to do that because it's hard with my pen. So the probability that X is less than 700 grams. Now notice how I haven't done less than or equal to here. With the continuous distribution, that equal to doesn't matter anymore. We're just saying less than, because 700 and 699.9999999 are the same thing. So do that and I get 0.58. Now I have to be careful because it says, oh, I might do an extra decimal place, 0.583, because it says calculate the percentage. So I'm going to answer it the way it wants, so 58.3%. Okay, next one, calculate the weight, the probability that a tuatara weighs between 600 and 800 grams. So your statement should look like this: 600 x 800. So probability that x is between 600 and 800, and in my calculator my lower is going to be 600 and my upper is going to be 800. Standard deviation and mean is still the same. So now I get 0.697. It doesn't ask me to change this one to a percentage, so that's my final answer. Next one, calculate the probability that a tuatara weighs less than 500 grams. So I know I didn't do it for the last one, but diagrams always help you see what's going on. 500 is down here. So 500 is going to be my upper limit. So in my calculator, my lower limit again is negative, big number. My upper is 500. And I get 0.029. So the probability that x is less than 500 is equal to 0.0, I forgot what it said, 29. Now remember, you should be writing standard deviation equals 95, mean equals 680, lower equals negative 999, and so on, and upper equals 500. You need to write this in your paper because there's another way of doing it, which is a calculation, so they'd want to see evidence that you knew what you were doing in your calculator. Okay, next one. There are about 50,000 Tuatara living on Stevens Island in Cook Strait, but how many would you expect to weigh more than 550? So first of all, I need to work out the probability that x is greater than 550. Oh, that says 500. 550. Okay, so my calculator, I haven't given much space for that. So in my calculator, I'm saying it's greater than 500, so my lower is going to be 500 this time, and my upper is going to be a big number. So 999. Mean and standard deviation are the same, so the probability is 0.97. Now, it says there are about 50,000 Tuatara. How many would you expect to weigh more than 550 grams? So 97% are going to weigh more than 550 grams. So I need to go 0.97 times 50,000. Okay, so 50 times 0.97. So 48,500. 48. Now that'll depend on how you've rounded your work. I rounded it to 2 decimal places. If you rounded a few more, you'd have a slightly different answer there. Okay, and then explain whether or not the normal distribution is appropriate for the situation. We need to look at the requirements for normal distribution. So I would like you to read a certain page. I'll post it in the assignment. But so these are the requirements: that it's continuous, clustered around a single value, no lower or upper limits, and symmetrical. And then we have to relate it back to our situation. So continuous, weight is a continuous variable. So a continuous variable, remember, is something that can be measured rather than counted. It should be clustered around a single value. So this is usually true for things like weight, height, IQ, etc. There's a value that most people, that has the highest chance of happening, and then as it goes above or below that, the chance of being that height or weight or having that IQ gets lower. So we draw it. So this is the mean, and people are, as you go further away, people get less and less likely to be really short and less and less likely to be really tall. No upper or no lower or upper limit. So a Tuatara can't weigh 0, so no upper or lower limit means this gets closer and closer to a value at the bottom, but never gets there. So it's like an asymptote. That the x-axis is like an asymptote, and here as well it gets closer and closer to the value to 0, the probability being 0, but it never reaches it, and so there's no limits. Now here the weight can't be 0, and it can't go less than 0, so you could effectively say that's a limit, but it's actually not ever going to reach 0. It's going to get closer and closer and closer, down, 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 but it's never going to reach there. And then finally, symmetrical. So we can't be sure that the spread of weights is the same above and below the mean for this case, but potentially we could assume it is. So overall, based on it definitely meeting these three and potentially meeting this one, we're going to say that normal distribution is appropriate. Did I record that?